Picture a glass sitting on the edge of a table. A sudden vibration, a slight breeze, or a careless brush of a hand sends it over the edge. You watch it fall in slow motion. You know exactly what is about to happen. The glass hits the hard floor, and with a sharp crash, it shatters into thousands of jagged, glittering fragments. The water inside splashes everywhere, soaking into the wood or the carpet. Now, I want you to imagine something very strange. What if you kept watching that puddle of water and those shards of glass, and suddenly, the water began to pool itself together, defying gravity, creeping backward across the floor? The thousands of scattered glass fragments vibrate, lift into the air, and violently snap back together, perfectly sealing every microscopic crack and fissure. The fully formed glass catches the flying water, leaps backward up into the air, and sets itself gently back onto the edge of the table, completely undisturbed. You have never seen that happen, and you know with absolute certainty that you never will. But here is the greatest, most unsettling mystery in all of modern physics. The fundamental laws of the universe do not forbid that from happening. There is no physical law that says the glass cannot reassemble itself. So why doesn't it? Why do things only happen in one sequence? Why does time only move forward? Hi, Questers! Welcome to QuestHut. Today, we are going to look at the invisible architecture of reality, and we are going to discover why your life and the entire universe is trapped on a one-way street. To understand why time has a direction, we first have to face a shocking truth about physics. If you open a textbook and look at the core equations that govern reality, Isaac Newton's laws of motion, James Clerk Maxwell's equations of electromagnetism, or Albert Einstein's theories of relativity, you will find something missing. There is no arrow of time. These equations work perfectly fine whether you run the clock forward or backward. If I show you a video of two perfectly smooth billiard balls rolling across a frictionless table, colliding and bouncing apart, and then I play that exact same video in reverse, you would not be able to tell which version was the original. The physics of the backward collision are just as mathematically valid and physically realistic as the forward collision. At the fundamental microscopic level of atoms and particles, the universe is entirely time-symmetric. The equations simply do not care about the past or the future. To an atom, before and after are meaningless concepts. So, if the microscopic building blocks of the universe don't experience a direction of time, where does our experience of the arrow of time come from? Why do we age? Why do mountains erode? Why do stars burn out? To find the answer, we have to zoom out. We have to leave the world of individual atoms and look at systems that contain trillions of them. We have to go back to the broken glass. When the glass falls and shatters, a profound shift occurs in the arrangement of the universe. Before it falls, the glass is one highly organized object. The silicon and oxygen atoms are locked into a very specific rigid lattice. There is a precise geometry to it. But after it hits the floor, it becomes thousands of scattered, chaotic fragments. We instinctively call this disorder or chaos. But physicists have a much more precise word for it. They call it entropy. Most people hear the word entropy and they think it just means things get messy. But entropy is not a measure of how messy your room looks to human eyes. Entropy is a measure of probability. It is the number of possible ways that the microscopic components of a system can be arranged while still looking the same on the macro level. Let me explain that with a simple analogy. Imagine your bedroom. There is exactly one way for your room to be perfectly, flawlessly clean. Every shirt is folded in a specific drawer, every book is alphabetized on the shelf, the bed is made with military precision. That is a state of very low entropy, because there is only one specific arrangement of items that creates that exact clean state. But think about how many ways your room can be messy. You could have one sock on the bed and one on the floor. You could have 3 books on the desk and a jacket draped over the chair. You could throw your clothes into the air and let them land randomly. There are billions, perhaps trillions, of different arrangements of your belongings that all qualify as a messy room. If a blindfolded person walks into your room and starts throwing things around at random, what is the statistical probability that they will accidentally fold all your clothes
organize your books, and make your bed. It is statistically zero.
Not because the laws of physics prevent a shirt from flying through the air and landing perfectly folded in a drawer, but because there is only one way to get it right, and a trillion ways to get it wrong. The room naturally moves toward a messy state simply because the messy state is overwhelmingly more probable. This is the secret of entropy, first unlocked by the brilliant physicist Ludwig Boltzmann in the late 19th century. Time moves toward what is more probable.
A shattered glass is vastly more probable than an unshattered glass. A melted puddle of water is more probable than a highly structured crystalline ice cube sitting in a warm room. If you open a bottle of expensive perfume in the corner of a room, the fragrant molecules will drift out and spread across the entire space. Will they ever spontaneously reverse direction, gather themselves together, and march back into the tiny neck of the bottle? The laws of physics allow it. If every molecule perfectly reversed its trajectory and velocity at the exact same moment, they would all go back inside. But the odds of that happening by sheer chance are so astronomically low that you could wait for trillions of times the current age of the universe, and it would never happen.
The arrow of time is simply the arrow of probability. The universe is not being pulled forward by a magical force. It is simply shuffling its deck of cards and moving blindly from states that are unlikely to states that are extremely likely.
But this realization brings us to a massive, terrifying paradox. It is the deepest question in all of cosmology. If entropy always increases and the universe is constantly moving from order to disorder, from the improbable to the probable, then why was there ever any order in the first place? Think about it. If the natural state of the universe is maximum chaos, maximum entropy, and perfectly mixed probability, why wasn't it already in that state yesterday or a million years ago? Why are there structured galaxies, highly ordered stars, intricate planets, and complex biological organisms like us? If you trace the arrow of time backward, entropy must get lower and lower and lower. To understand why time exists today, we have to rewind the clock 13.8 billion years. We have to go to the very beginning. Right after the Big Bang, the early universe was incredibly hot and incredibly dense. It was a searing plasma of fundamental particles. But strangely, defying all common sense, it existed in a state of spectacularly, mind-bogglingly low entropy. The distribution of matter and energy was incredibly smooth and uniform, like a perfectly wound, incredibly tight mechanical spring. Physicist Roger Penrose once calculated the probability of the universe naturally beginning in a state of such low entropy by sheer chance.
The number he arrived at is 1 out of 10 to the power of 10 to the power of 123. That is a number so large that if you wrote a 0 on every single atom in the observable universe, you would run out of atoms long before you finished writing the number.
The universe began in a state of almost impossible, perfect order. Physicists call this the past hypothesis, and it is the only reason anything is happening right now.
Because the universe started in this ridiculously low entropy state, it gave reality room to breathe. It gave the cosmos a thermodynamic slope to roll down.
The increase of entropy, the unwinding of that cosmic spring, is what powers the stars. It is what drives the chemical reactions in the soil. It is what fuels the chaotic, beautiful machinery of life. And that increase of entropy is what gives time its direction. If the universe had been born in a state of maximum entropy, a perfectly mixed, lukewarm soup of chaotic radiation, nothing would ever happen. There would be no stars to catch fire. There would be no planets to form. There would be no biology. There would be no past, because the past would look exactly like the future. There would be no arrow of time. Time as we experience it would simply not exist. This deep cosmic reality is intimately connected to your personal experience of life. Think about your own mind. Why do you remember yesterday, but you do not remember tomorrow? We tend to think of memory as a mystical, ethereal thing, but memory is a physical process. To remember what you ate for breakfast, your brain had to physically alter itself.
Neurons had to fire. Synapses had to form new connections. Chemical neurotransmitters had to be synthesized and pumped across microscopic gaps.
All of that physical, biological machinery requires energy. Your body burns glucose to power your brain, and in doing so, it radiates heat out into the environment. By forming a memory, your brain has actively increased the entropy of the universe.
A memory is a physical trace, a record left behind by an event that happened in a lower entropy past. The future hasn't happened yet, which means the universe has not yet transitioned into those higher entropy states required to leave a trace in your brain tissue.
You do not remember the future for the exact same thermodynamic reason that shattered glass does not reassemble. Remembering the future would require entropy to spontaneously decrease. It would require the universe to unburn energy. And statistically, the universe does not do that.
This brings us to the ultimate, deep realization about the nature of reality.
We are taught to think of time as a river, flowing relentlessly forward, carrying us against our will from the past into the future. We think of time as a fundamental force, a pushing mechanism that drives the universe.
But physics tells a different story. Time isn't a river. It isn't a force. It isn't even truly a fundamental property of the universe in the way mass or electric charge is. Time is an emergent phenomenon. It feels like it flows only because we are biological machines moving from a highly improbable state to a highly probable one.
We are moving from a universe of strict, tight order toward a universe of vast, cold freedom of arrangement. From the structured constraints of the Big Bang to the quiet, chaotic equilibrium of the far future. You are not traveling through time. You are surfing a localized wave of increasing entropy. The glass shatters upon the floor because there are vastly more ways to be broken than to be whole. The ice cube melts in your drink because the fast-moving water molecules in the warm air violently collide with the frozen lattice, sharing their kinetic energy until everything is a perfectly probable lukewarm mixture.
You grow older, your skin wrinkles, and your cells degrade because the biological processes that keep you alive are constantly battling the overwhelming probability of molecular disorder.
Time only moves forward because chaos is more mathematically probable than order. And somewhere out there, 13.8 billion years in the past, a spark ignited a universe so utterly perfect, so specially ordered, that it gave us the gift of this long, beautiful, one-way journey into disorder. So the next time a glass slips from your fingers and crashes onto the floor, do not just sigh and reach for the broom. Stop for a moment. Look at the scattered shards. Remember that you are not just watching gravity pull an object to the ground. You are witnessing the fundamental law of probability asserting its dominance. You are watching the echo of the Big Bang. You are watching the arrow of time in its purest, most undeniable form.
If the fundamental laws of physics truly allow for time to move backward at the microscopic level, what would a fully reversed macroscopic universe even look like to someone living inside it? If you were born in a universe where entropy decreased instead of increased, how would you experience a conversation? Tell me your theories in the comments below. And as always, keep questioning everything here at QuestHut.